Hi, my name is Chris McHenry and I'm a Technical Solutions Architect with Cisco. Today we're going to focus on Cisco Tetration and how we can leverage Tetration to help us implement a Zero Trust network security architecture inside of our data centers. Now, in previous videos, we've taken a look at how some of the discovery capabilities of Tetration can help define policy in things like external firewalls or AWS security groups. But today we're going to look at some core features inside of the product itself that allow us to actually implement that segmentation and operationalize that segmentation, leveraging Tetration's own capabilities in an infrastructure agnostic environment. Now, before we jump into the demonstration, I do want to talk a little bit about why we're looking at doing this in the first place. Zero Trust has been a term that's become significantly more popular in the industry over the last several years. Now, network segmentation has been around for a really long time. In fact, it's called out as, there's a number of sections in a lot of the regulation, the regulatory compliance environments, things like PCI and high trust in healthcare, that mandate having a good handle on how we segment our environments. Because if we can implement segmentation well, we can start to drive security policy away from the edge of the network. And we can start to disrupt attackers as they're getting inside of the environment and keep them from, even if they initially exploit something, from moving laterally inside of the environment. In fact, when we look at the typical intrusion phases of an attacker, the first 4 bullet points here are places that we've primarily focused on. We've looked at how can we prevent someone from getting in the first place? How can we prevent someone from installing a virus or establishing persistence? The reality is that I think we're at a point where it's a given that this is going to happen at some point in time. And so we need to focus on disrupting attackers as they get further down the stack. So when we look specifically at this next phase, the move laterally phase, this is one of the, maybe the most effective security mechanisms, but also one of the most challenging to implement, because it requires a really deep understanding of how our environments work if we're actually going to be able to implement and operationalize it. And as we drive policy further and further down, it also exponentially increases the number of policies that we need to manage. So let's take a look at what it means to move laterally in an environment. Now, today, we build data centers a lot like this. We have security that sits on the edges. We might have some basic segmentation in the environment. But the reality is that what this actually looks like is it looks like a hotel where you go to the front desk and they check your ID, and then you go up to your room, and then when you get to your room, all of your doors are unlocked. You can walk into anyone's room, you can steal their stuff. I mean, the problem is that it's really challenging to actually drive segmentation further in the environment. But this is how we do it today. And so what happens is when we get an attacker, they might actually get into a single part of the data center, but once they get in, they can move to anything else that they want to in that environment. Now, that initial intrusion could look completely legitimate. It could be because they'd phished someone and got a legitimate set of credentials. But even in that scenario, there's no reason that the web services tier should be communicating with the file sharing system. And so we have another opportunity to prevent that attacker from getting the data that they want to get. Now, this all looks nice on the surface, and we've had the tools to actually implement this segmentation for quite some time, but one of the problems is that applications in modern data centers are extremely complex. In fact, we talk about this idea of a mythical 3-tier application, but there really isn't a 3-tier application in an environment. Even relatively simple applications look more like this. Now, this is a screenshot from Tetration of a policy discovery that we did at Cisco IT as we were working on implementing our own Zero Trust segmentation. And you can see here that very quickly, while this middle area here is built around how the user interacts with an application, 6 distinct tiers in this individual application. Very quickly, if I were to actually whitelist it, the policy is going to get significantly more complex when I start to consider how do users interact with the application, and how does it back up to other data centers, and how does it get software updates, and how does it communicate with config management and AV update services and DNS and all the other components that are required for this thing to actually operate. So this is one of the challenges that we're trying to solve with Tetration, and our goal is to actually build out something that allows us to operationalize Zero Trust, focusing on multiple different components of the problem, both the discovery and definition of the policy, to the actual implementation of the policy, to actual verification that the policy is being enforced down the road. And so you can see Tetration is designed as a platform, right? Part of this is data collection and understanding what's going on. And a lot of it's built on the ability that Tetration has to automatically discover and map application dependencies. So we start with this visibility and application insight piece. Being able to discover the applications first allows us to then generate that security policy. Now, before we build and actually implement that policy, we could take it and we could export it to an environment that we want to use enforcement in outside of Tetration itself. But we can also leverage the native application segmentation capabilities that Tetration has. And we'll talk about that as we jump into the demo. And then after we actually implement the segmentation, we can monitor it for compliance. So with that, let's jump into the demonstration. We'll take a look at what we mean when we're talking about this. So we're going to focus today on an open source inventory management system that's built like a web services, a traditional web services application. This actually is a 3-tier app. We've got a web tier and a database tier, a user tier, and a couple load balancing tiers. But you can see it's fully functional. And in this same environment, I also have another machine. And just to give you an example of the type of thing that an attacker can actually exploit when they're simply adjacent to something in the network, we're going to run a quick scan on this particular environment. So again, we're going to assume that this machine has been hacked by an attacker. We're going to be scanning an individual machine inside of our invoicing system. And even though there's no reason that this attacker's machine should ever communicate with anything inside of that invoicing system, just by nature of the fact that it sits in the same subnet, it's able to see a number of extremely detailed pieces of information about that system. So not only can I tell you that it's listening on web services ports, but I can tell you that SSH is open, and here's the exact version of SSH. So an attacker could very quickly, even without credentials, see that this would be vulnerable to Heartbleed, or that this particular server is running an Apache server, what version it is, and that it's actually implementing PHP web apps. So I have a lot of information about how I could potentially exploit this based on the services that it's running. Now, we should never even get to this phase, right? Because there's no reason that this particular server should be communicating with this other application. The problem is that deep microsegmentation like this has been extremely hard to do at scale because we both need to discover the policy and implement the policy. Now we can also ping this system, so I'm going to run a ping here while we jump into Tetration and talk about how we can take the environment from something that looks like this to something that's significantly more secure. Now the first phase of doing this is looking at how we can discover the application. And Tetration is designed to do this independent of the infrastructure, independent of how big the environment is or how many endpoints that we're looking at. We're focusing in this example on this particular application, but we could obviously do this in a much larger environment. And what Tetration has done is, up until this point, I've done nothing other than install the Tetration sensors on the servers that are part of my invoicing application. And after a little while of collecting data, Tetration runs its machine learning algorithms against that information, and it comes up with this consolidated policy that we could then use to implement. Now it does two specific things. It's looking for different tiers and roles inside of that application. You can see Tetration has discovered this web services tier, and it's put 3 individual OSs or virtual machines inside of that particular tier. Now this is done automatically, and you can see that this is built out with our machine learning algorithms because it gives us a confidence score that's associated with that, which means I've done nothing to actually group these things manually. This allows us to get a really consolidated set of policy in our environment and to reduce the number of policies that actually have to be implemented. Now you can also see the relationships between different tiers so that when a user reaches out to the web tier, they're reaching out over port 80 and over this particular load balancer VIP, and the same thing for this web services tier communicating with the database tier. But even in this environment, this is not the whole picture, right? Even in a relatively simple 3-tier application, we've got a lot more complexity in this environment if I were actually to implement microsegmentation. So as I build this out, right, you can see that we also need to have policies that allows the web tier to communicate with DNS servers and allows it to send data back into Tetration and to communicate out with the internet for things like software updates. So having Tetration discover this policy is a critical component to actually being able to operationalize and implement it. Now once we get to this point, we can also edit that policy, and we can visualize it in a couple different ways. So in this scenario, I'm going to actually look at this policy like a traditional firewall policy would look like. This makes it a lot, very easy to see the individual relationships, to look at the ports and protocols. We can search among, this particular environment as well. Search is a huge component of the Tetration platform. We can also edit the policy, but we're going to come back to this in just a second. Once Tetration has discovered the policy, we also have the ability to simulate it. And Tetration is going to monitor in real time all of the traffic in the environment, and it's going to map it in the same way that a firewall would map it, Was this particular packet permitted through this particular rule, or was it rejected? Now what's interesting is because Tetration is also monitoring things that may not actually see an enforcement device, we can also categorize things that should have been dropped or things that were dropped by accident. And this allows us to simulate and verify the policy in advance of actually applying it. One of the big challenges with driving segmentation into the environment is that segmentation is designed to break things. And so we need to have an extremely high level of confidence prior to actually implementing it. So in advance, as we're simulating the policy against the real world environment, we can use this to make sure that we're going to, once we implement it, it's correct. After we've actually implemented it, we can actually use this real-time monitoring for things like compliance. So for instance, if all of a sudden I see someone reaching out to a database server and I see that policy is either being rejected or for some reason that connection was allowed, we can report on that and alert on it and send it out to something like a SIM system. Now, once we've gotten to a point where we're confident that our policy is actually going to be enforced, inside of Tetration, we have native ability to actually enforce this policy. And so when we move to the Enforcement tab, all I'm going to do is click Enforce here. And what this is going to do is this is going to, on every server that has the Tetration sensor installed, Tetration is going to calculate a unique firewall rule set that it's going to then implement in the native firewall mechanisms that happen inside of that operating system, things like IP tables and IP sets and Windows Advanced Firewall. Now this allows us to essentially build a giant stateful distributed firewalling system inside of a data center, even if we don't have access to the infrastructure that lies underneath it. Now oftentimes we've talked about implementing microsegmentation at an infrastructure level, but that tends to break down when we look at how do we implement this segmentation across multiple different cloud-like environments. Leveraging this mechanism, we can have a single set of policy that's implemented across both your internal infrastructure, across a colo, and even across services like AWS. Now you can see when we go over into our environment over here, because my attacker was not part of the policy, our pings have stopped. And as we go in and we start to run a scan, you'll see that the results of this scan give us almost no indication of what the adjacent server has done. Now keep in mind, we've done nothing to the infrastructure. This is entirely natively leveraging the capabilities of Tetration. The critically important part here though is that the user experience stays exactly the same. So we've implemented policy in a way that allows the application to completely be fully functional in the way that it's designed to be functional, but doesn't allow any other alternative access mechanisms. And essentially what we're doing is we're pushing security policy all the way down into the environment with the exact level of granularity that's required to make sure that the environment functions properly. And if we go back to our attacker over here, you can see different results this time around. Nothing is discovered in terms of how that particular system could be exploited. Now let's change this thought process real quick, and let's assume instead that this particular system is a new system I brought onto the network and it's a scanner. And that's a good thing. We want to have consistent security scans in our environment so that we can tell whether things could potentially be vulnerable. So I want to enable this particular service. Now Tetration also, like I mentioned before, gives us the ability to edit policy. But we can do this in a way that's a little bit easier than what we've done in the past in terms of being able to, instead of thinking about how a particular IP address or a particular server communicates with another server, we can start to implement business level, what we call intent-based policies. Now these policies can be based on all of the information that Tetration has about the environment, both information that it's collected itself and information that it's collected from other sources, things like CMDBs, things like VMware, AWS, inventory management systems, IP address management system, things along those lines. And we can write this intent-based policy in a way that makes sense from a business perspective. So oftentimes we'll see customers whose security teams will have a high overarching policy that will say things like, no PCI services should ever talk to non-PCI services. And not only will Tetration be able to monitor whether that policy is ever violated, it'll actually be able to enforce that policy based on the understanding that it has of the environment. In this environment, we have a definition for scanners. And we're going to set a policy that says, I'm going to allow all scanners to ping any service that might exist in the environment. We're going to go in, we're going to edit that policy. We can simulate that policy before we actually apply it so that we know that it wouldn't break anything, and then we're going to enforce that policy. Now again, in real time, Tetration's recalculating what policies should actually show up on the environment. And if we start this ping up again, it takes about 15 seconds sometimes for the policy to actually get pushed down. But what you'll see is this machine has now been reclassified into the scanner organization, and it's going to start having the ability to communicate out with the application that's adjacent to it. So you can see our pings have started up again. What this brings with Tetration is kind of a full circle, a full suite of capabilities that allow us to truly operationalize large-scale segmentation in the environment. And we can bite it off in different chunks as well. So if we want to start out with a small set of applications that you want to very quickly bring segmentation to and scale out over time, Tetration has the capability to do that without making any major changes into your environment. Now, if you like this or if you have any questions, feel free to comment on the YouTube video or reach out to your local Cisco contact. We can have definitely a more customized or in-depth conversation. But thank you for your time. Thank you for listening. And like I said, if you have any questions, feel free to leave them in the comments section. Thank you.